Today, we're going to be looking at a really critical part of modern security, identity, specifically within zero trust architecture. You've probably heard the term zero trust before. Maybe you've even wondered how it actually works in practice,
Mm.
day to day.
Mm.
So we're going to break down a core concept here, and that's identity.
Right. And when we talk about identity
Mm.
in the context of zero trust, we're talking about way more than just like a username. It's a whole bunch of details. Think of it as a digital profile for a person or a system. And this data lets us answer some really fundamental questions when it comes to security.
Exactly. We're talking about questions like who or what is trying to get into stuff on our network? How sure are we that, they are who they say they are? Do we trust all the information they're presenting? And maybe even more importantly, do we have enough specific info about them to make smart decisions about who gets access to what based on our security rules?
And this isn't just some kind of abstract theory. Lots of organizations are really struggling with how to understand and actually manage all these digital identities. Recent surveys even suggest that a good number of companies think their identity management strategy just isn't quite where it needs to be for good security.
Right. So what we're trying to do today is give you some clarity, offer some actionable insights. So whether you're like a seasoned IT pro deep in the trenches of security or just someone who's curious about how modern networks are defended, we want to give you a solid grasp of identity.
So let's start with the basics. Identity isn't just one part of a zero trust strategy. It's the foundation. For zero trust to actually work, the principles of managing identity have to be everywhere, throughout your entire digital space. This is what makes it possible to have flexible and very specific rules about who can do what. And that's at the core of a really strong zero trust approach.
That point about it being everywhere, that's key. It has to touch everything. Think back to the old way of doing network security. It's often shown as like a really well-defended outer layer, right? Like a hard shell protecting a kind of trusting and maybe vulnerable inside network.
Yeah, and zero trust basically turns that model upside down.
Mm.
Instead of just assuming things are trustworthy because of where they are on the network, zero trust works on the idea that nothing and no one is automatically trusted, whether it's inside or outside that traditional network perimeter.
So if the network perimeter isn't the main control anymore, what is? What takes its place in keeping things secure?
That's where identity comes in. Identity becomes the checkpoint, the thing you have to verify every single time someone wants to get to a resource. It's about definitively knowing who or what is trying to get in, and then using that information to decide what security controls are needed. And this verification isn't just once and done. It happens every time someone tries to access something. It doesn't matter what happened before or where the user is on the network.
Okay, so that makes sense. Identity is the new central control. So to manage these identities in a zero trust world, what are some of the must-haves, the things organizations need to have in place?
Right. So obviously the specifics are going to be different for each organization depending on their setup and what risks they face. But there are some core capabilities that make up the foundation of identity management in a zero trust model.
All right, let's go through them one by one. You mentioned AAA first. What does that actually involve?
Yeah, you've probably heard of AAA, authentication, authorization, and accounting. It's the foundation for managing access control, who can get to what and what they can do once they're in. So first, authentication. That's about verifying the identity of a user or a device, proving they are who they claim to be. We're talking about things like usernames and passwords, maybe even multi-factor authentication or even biometrics in some cases. Understanding AAA isn't just theoretical. Without good authentication, anyone could pretend to be someone they're not, which would make all those other zero trust controls totally useless.
Okay, so authentication is all about confirming who they are. What comes after that?
Once a user or device is authenticated, then we have authorization. That decides what they're allowed to do or access. It means checking their permissions and looking at the security policies to see if they're allowed to access the specific resource they're asking for. For example, think about an employee who successfully logs into the company network but is only allowed to access files and applications related to their job, nothing else.
Got it. And accounting is just about keeping track of all of that, right?
Exactly. Accounting means keeping logs and audit trails of all the activity. It creates a record of who accessed what, when, and what they did. This information is super important for security monitoring, for responding to any incidents, and for meeting compliance requirements. It lets you trace everything back to a specific identity, someone who's been verified.
Okay, so that's AAA, the core of it all. What's next? You mentioned certificate authority and PKI. Can you unpack those a bit?
Yeah, so certificate authority, it's often talked about under PKI, public key infrastructure. And it's becoming even more important with zero trust, especially for making sure communication is secure and encrypted. PKI relies on digital certificates to confirm the authenticity of systems, users, even applications.
So how do these digital certificates actually work to verify someone's identity?
Think of a digital certificate like a really secure, tamper-proof ID card. It uses cryptography to link an identity, like a user's name or a server's web address, to two keys, one public and one private. These certificates are issued by a trusted certificate authority, which is basically like a digital notary public. Because a trusted authority vouches for the certificate, it's almost impossible for someone to fake one. That gives you much more confidence in the identity than just a password. When two systems, or a user and a system, need to talk securely, they use these certificates to verify each other and set up an encrypted connection. The private key stays secret, while the public key can be shared openly.
So it's kind of like a secure digital handshake, right? It confirms who they are and also sets up a safe channel for communication.
Yeah, exactly. Because it's so hard to forge these certificates, they provide a really strong level of confidence in the identity of everything that's communicating. And that's super important in zero trust, where we don't just automatically trust something based on its location on the network.
Okay, that makes sense. So the next thing was network access control, or NAC. Where does that fit into the whole identity picture?
Network access control is like the first line of defense, the gatekeeper for your network. Its job is to figure out which users and devices are allowed to connect to the network in the first place. NAC looks at the identity and the security status of the device and the user to enforce security policies.
So before someone even gets on the network, NIC is checking them out, making sure they are who they say they are and that their device is secure.
Absolutely. NAC can authenticate both users and devices before they get any access to the network. It could even check the security of the device, things like if it has the latest antivirus updates or if the operating system is patched. If it doesn't meet the requirements, it might not be allowed on the network, or maybe it gets put into a quarantine area. This can be used for wired and wireless networks in your offices and also for remote access, like when people use VPNs.
So NAC is the first identity checkpoint at the network's edge. What happens once they are on the network? That's where provisioning comes in, right?
You got it. Provisioning is about managing the entire life cycle of identities for both users and devices. It starts with onboarding, like when you have a new employee and they need to be set up with all the access they need to do their job. Things like network logins, email accounts, access to the applications they need to use.
So it's like creating their digital identity within the company, right? Making sure they have everything they need to function in their role.
Exactly.
Yeah.
But it's not just creating accounts. It's also about managing all the details associated with those accounts, giving them the right permissions based on the roles and responsibilities, and making sure their identity info is the same across all the different systems. And importantly, it also includes what we call offboarding. When an employee leaves the company or a device is retired, their access needs to be taken away to prevent any unauthorized access.
That offboarding part sounds really important from a security perspective. I mean, if you don't do that properly, you're basically leaving a door open, right?
It's super important. A lot of times it gets overlooked.
Oh.
But not taking away access when someone leaves or a device isn't being used anymore can create security risks. You could have all these unused accounts just sitting there, which would be used by attackers. Effective provisioning is about making sure the right people and devices have the right access at the right times, and that access is taken away quickly when it's not needed anymore.
Makes sense. We talked about getting users and devices onto the network and managing their basic access, but what about those with higher level access? The people with more control. That's where privileged access management, PHAM, comes in, right?
Yes, PHAM, or Privileged Access Management, is all about controlling access for things like administrator accounts, the accounts that can make big changes to systems and data. Securing these accounts is really, really important in zero trust because they have so much power.
So it's about making sure only the right people have those keys to the kingdom and that we're watching how and when they use them.
Exactly. With PM, you're putting much stricter controls around the use of these special accounts. This can mean things like enforcing multi-factor authentication just for those logins, setting limits on how long they can have access for, and closely monitoring and auditing everything they do. The main goal is to be super sure that these powerful credentials are only being used for legitimate reasons, and that if there's any misuse, it's caught and dealt with immediately.
Okay, makes sense. You definitely don't want to leave those high-level keys lying around where anyone can grab them. Now, something that's pretty common these days is multi-factor authentication, or MFA. How does that fit into identity security in a zero-trust world?
Even though MFA has become more common, especially with so many people working remotely, it's still super important for verifying identity in a zero-trust model. MFA basically means you have to provide more than one form of ID before you can get access to something. That makes it much harder for unauthorized access to happen, even if someone steals your password.
So it's like proving who you are in a few different ways, right? Like not just something you know, but something you have, or even something you are.
Exactly. The common categories for MFA are something, like a password or PIN, something you have, like a smartphone with an authenticator app or a physical token, or something you are, like a fingerprint or facial recognition. By requiring multiple factors, MFA makes it much harder for attackers to get in. Even if they somehow steal your password, they still need those other things. In Zero Trust, the key is to use MFA as much as possible for as many access points and important resources as you can.
And you mentioned earlier that getting the user experience right with MFA is really important. Why is that?
User experience is absolutely critical. If people think the MFA process is too much of a hassle, or if it keeps interrupting their work, they might get frustrated and try to find ways to bypass it, and that defeats the whole point. The goal is to have strong security that doesn't get in the way of people doing their work. So, you might use what's called risk-based authentication. That's where MFA only kicks in when there's something suspicious happening, or when someone is trying to access really sensitive information instead of every single time they try to log in.
That's a really good point. Security has to be usable for it to actually work. So let's switch gears a bit here. You mentioned asset identity. How is that different from user identity in a zero trust world?
Asset identity focuses on figuring out and keeping track of all the devices on the network that aren't directly tied to a person.
Hmm.
So we're talking about things like IoT devices, the Internet of Things, and OP equipment. That's the stuff used in industrial settings, servers, and even the devices that make up the network itself. In Zero Trust, these things also need to have a verifiable identity and have security policies applied to them just like we do with user accounts.
Because even though they might not have a human user directly interacting with them, these devices can still be targeted by attackers, right? Or they could be used as a way to get into other systems.
Exactly. A lot of these devices don't have the same kind of user interfaces or traditional ways to authenticate that we use for user accounts. So figuring out their identity often means looking at different things, like their MSC address, their serial number, the version of the software they're running, or any digital certificates they have. Knowing exactly what these assets are and understanding their current security posture is really important for enforcing specific policies and preventing anything malicious from happening, whether it's coming from those devices or directed at them.
And you mentioned a connection between asset identity and the configuration management database, the CMDB. What's the relationship there?
Right, so the CMDB is like a central database with info about all the IT assets in an organization. That includes hardware, software, and how everything is configured. How accurate and complete that database is really important for setting up and keeping track of asset identities, especially for those devices that don't have users logging into them.
So the CMDB provides the context, all the specifics about those assets to help verify who they are and what their function is.
Exactly. A good CMDB should have all the key info about every asset that can be used to know what it is and how risky it might be. That information is then used by other security tools and platforms to apply the right security policies. For example, knowing what kind of IoT device it is, like a temperature sensor or a security camera, helps you figure out which other parts of the network it should be allowed to talk to and what kind of network traffic is normal, what's expected for that specific device.
So a well-maintained CMDB is pretty much a must-have for managing asset identity well in a zero-trust architecture. The last thing on our list of key capabilities was IP schemas. How do IP addresses fit into all of this in today's networks?
So in the past, IP addresses were often used as the main way to identify devices on a network, especially when networks were mostly divided using VLANs and subnets. But with all the new networking tech, using IP addresses alone to identify things isn't as reliable as it used to be.
Because IP addresses can change, right? And they don't always tell you exactly which user or device you're dealing with.
Right. Things like DHCP, Dynamic Host Configuration Protocol, the devices can get different IP addresses over time. And then you have NAT, Network Address Translation, which can hide a lot of devices behind a single public IP address. But even though they're not the main way to identify things in Zero Trust, IP addresses can still be useful. They can give you some context in certain situations.
Can you give an example of when an IP address might still be a useful piece of information when it comes to identity?
Sure. Let's say you have a vendor or a partner who needs access to your internal network. And they do this through a dedicated, well-defined connection. In that case, knowing the range of IP addresses their traffic is coming from could still be useful for your access control policies. Or knowing the static IP address of a really important server might help security analysts understand what's happening when there are access attempts, even if the main way to verify identity is something else, like digital certificates or user logins. So even though they aren't the main thing anymore, IP addresses can still be a piece of the puzzle, providing valuable context in specific cases.
Okay, so that gives us a really good overview of all the important things we need to think about for managing identity in a zero trust model. To make it all work, we need to know where all this data comes from and where it ends up, right? Let's talk about the identity ecosystem, the providers and the consumers of this information.
Absolutely. To effectively manage identity in a zero trust setup, you need a clear picture of where all the data is coming from, where it's being stored, and then who is using it to make those security decisions and enforce policies.
So let's start with the providers. Where does all this crucial information usually come from in an organization?
There are a few key systems that are usually the main providers of identity data. One of the most important is the HR system, the Human Resources Management System, or HRMS. Systems like Workday or SAP SuccessFactors, they're often the starting point for user information right when a new employee joins the company.
So when someone new starts working, their basic information, like their name and job title, all that goes into the HR system first.
Exactly. That initial data from HR, things like their name, employee ID number, what department they work in, what their specific job is, all of that is often used to create their user accounts and give them access to other systems. The HR system is the source of truth for a lot of user identity information.
That makes sense. It's the central place for all employee information. What are some of the other systems that typically act as identity providers?
Another big one is directory services. These are systems that are specifically designed to manage user and computer accounts and other directory information. You've probably heard of Microsoft Active Directory, or LDAP, which stands for Lightweight Directory Access Protocol. These are the systems that handle authentication, verifying user logins, and they often have a lot of detailed information about users, like what groups they're in and what permissions they have.
So when a user tries to log into a system or application, they're being authenticated against the directory service.
Exactly. It's the system that checks if their login info is correct, and it stores all that important information about their account that other systems use to make decisions about access and security.
Earlier, we talked about network access control, NAC. Can those systems also provide identity information?
Yeah, good point. NEC systems can actually act as both a consumer and a provider of data. When someone tries to connect to the network, the NEC system does the authentication and figures out the security status of the device, basically gathering info about its identity and how secure it is. Then, it can share that information in real time with other security systems. So NEC is a provider of identity information based on what happens when someone tries to connect to the network.
So let's say a device connects to the network. Its identity might be verified by the NEC system, and then that information is shared with something like a firewall, which uses that info to decide whether to allow access or not.
Exactly. That's a good example of how identity information flows within the ecosystem. Another important one is the Configuration Management Database, the CMDB. Like we talked about before, the CMDB stores all the details about an organization's IT assets. And that's really important for those devices that don't have traditional user counts, the ones that don't have people logging into them.
So for something like an IoT device where you don't have a username and password in the traditional sense, the CMDB might store things like its M address, model number, and what it's actually supposed to do on the network. And that information is used to identify it.
Exactly. The CMDB provides those identifying details for assets that don't have users interacting with them. Then you have Public Key Infrastructure, or PKI. It's a really important provider of identity, too. It does this by issuing digital certificates, both for users and machines. This is a strong way to verify identity using cryptography.
And because those digital certificates are so hard to fake, the information they contain about someone's identity is considered very trustworthy, right?
Exactly. PKI can include a lot of identifying information right in the certificate itself. And when authentication is successful using a valid certificate, you can be pretty sure that the user or device is who they say they are.
You also mentioned databases and mobile device management systems as potential sources of identity data. Can you talk about those a little more?
Sure. So while they might not be the main systems for storing and managing identity, traditional databases sometimes have user information that's needed for older applications or special systems. And mobile device management, or MDM systems, they provide information about mobile devices, which is really important when companies allow employees to use their personal devices for work. They can tell you who owns the device, if it's compliant with the company's security policies, even what apps are installed on it. All that can be used for identity and access control.
And lastly, you mentioned something called profiling systems.
Yeah, profiling systems are becoming really important, especially for figuring out and keeping track of all the IoT and OT devices that companies are using. These systems work by watching and analyzing how devices communicate on the network, the protocols they use, and their behavior. This helps them figure out what kind of device it is, who made it, and what it's supposed to be doing, even if it doesn't have traditional identity information like user accounts or servers. All that information is used to build an identity profile for the device, which can then be used to enforce security policies and detect anything suspicious.
Okay, so we have all these different sources providing identity data. Who's using this data? Where does it go to actually make security decisions and enforce policies?
The ones who use it the most are security enforcement platforms and security analytics platforms. Enforcement platforms are things like firewalls, NAC systems, and endpoint security solutions. They need accurate, up-to-date identity information to apply security policies and control who gets access to what.
So, for example, when someone tries to get to a sensitive file server, the firewall might check their identity information to see if they're allowed to access it based on their role or group membership.
Exactly. The firewall uses that identity information to decide whether to allow or block the traffic, based on the security rules that are tied to specific identities or groups. Same thing with NAC. It uses that info to decide if a device is allowed to connect to the network at all and what level of access it should have. And endpoint security solutions can use identity information to enforce rules directly on the user's device, depending on who's logged in and what they're allowed to do.
Makes sense. Those enforcement points need to know who's asking for access to make sure they're following the rules. What about those analytics platforms? How do they use the data?
Analytics platforms like CM systems, SRR platforms, and MBA tools, they use identity information to make their alerts more meaningful, understand how users are behaving, and spot potential security problems.
So instead of just seeing an IP address trying to access a database server, a CIAM system could connect that activity to a specific user account and all their information, right?
Right. By integrating identity data, these platforms can give you much more context about what's happening. So instead of just knowing an IP address triggered an alert, you know exactly who was using that IP address at that time. This makes investigating security incidents much faster, helps you figure out if accounts have been compromised, and allows for a more targeted and effective response. Like, if a user suddenly starts doing things that are out of the ordinary, accessing stuff outside of work hours or from a weird location, the analytics platform can flag that as suspicious because it knows their usual behavior.
Having that extra context sounds really important for being able to spot and respond to threats effectively in a zero-trust environment. So now that we know where the data comes from and who's using it, let's talk about how it actually moves between all these different systems. What are the main ways this data is exchanged?
The main way is through APIs, application programming interfaces. APIs are like standard ways for different software systems to communicate and share information.
So it's like a common language that different systems can use to talk to each other and exchange information?
Exactly. And there are different ways to use APIs for exchanging identity data. One common way is to build custom integrations, writing code that directly connects different systems. This gives you a lot of control, but it also has some things to consider.
So for instance, if our HR system and NEC solution don't have a ready-made way to connect, we could write custom code to allow them to exchange the necessary data.
Yep, that's definitely an option. This way, you can customize the integration to exactly what you need. You can control what data is shared and how it's formatted. This is especially useful when you have older systems or specialized applications that don't have standard integrations, or the existing integrations don't do everything you need.
But that sounds like a lot of work, right? A lot of coding and then having to keep it updated as systems change.
It definitely can be. Building and maintaining custom API integrations usually needs dedicated developers and technical expertise. You have to write the code, test it thoroughly, and then make sure it keeps working as systems get updated or changed. So yeah, it can add to the cost and complexity of managing your identity stuff.
So the other option would be to use integrations that are provided by vendors, right? If
Yeah.
those are available.
Yeah, exactly. A lot of software vendors offer pre-built integrations that connect their platforms with other common security and identity solutions. These are usually much easier to set up and manage than building something custom, since the vendor has already done most of the technical work.
So, for example, if we use the same vendor for our firewall and our identity management platform, there might be an integration we can use that's pretty easy to set up and manage.
Exactly. Those vendor-specific integrations can make things a lot easier, but the downside is that they might not be as flexible. You're usually limited to the data and features that the vendor has included in the integration. If you need more control or need to exchange data in a way that the pre-built integration doesn't support, then you might run into problems.
So, it's a trade-off between how easy it is to set up and how much control and flexibility you need. You mentioned that using standards is really important for data exchange. What does that mean when it comes to identity data?
When we talk about standards, we mean using protocols and data formats that are open and widely used. The advantage here is that it makes it much easier to connect systems from different vendors. If all your identity providers and consumers use the same standards for talking to each other, it's much easier to integrate them, no matter who made them.
So instead of being stuck with proprietary integrations that only work within one vendor's products, open standards allow for better communication and data sharing across different platforms.
Just exactly. When you're looking at integration options, look for ones that use established standards, things like SAML, Security Assertion Markup Language, or OAuth for authentication and authorization. And look for standard data formats for exchanging identity information. Using these standards can help you avoid being locked into one vendor and give you more choices in picking the best solutions for your needs.
And you mentioned PX Grid earlier as an example of a platform that helps with this kind of data exchange. Could you explain a bit more about how it works and why it's useful for Zero Trust?
Sure. PX Grid stands for Platform Exchange Grid. It's a platform developed by Cisco that's designed to help different security and IT systems share information in real time, including identity data. It uses a standards-based approach, mainly relying on the WebSocket protocol, which is good for efficient and continuous communication. And it uses structured data formats to ensure consistency in how information is shared.
So basically, different security tools and platforms can connect PX Grid and share information.
Yeah, think of PX Grid like a central nervous system for your security infrastructure. Systems that are connected to PX Grid can both publish the information they have, like confirmed user identities, device details, or even threat intelligence, and they can also subscribe to receive relevant information from other connected systems. This two-way flow of information helps you create a more coordinated and effective security approach across your whole environment.
You gave a few examples of how PX Grid can be used with identity data in Zero Trust. Can you go into those in a bit more detail?
Okay. One really common use case is providing that rich identity data to different systems. For example, Cisco ISE, which stands for Identity Services Engine, is a platform for network access control and policy management. It can act as a provider of identity context. And when it's integrated with PX Grid, it can share information like user roles, group memberships, and the security status of devices with other systems in real time. And those systems can then use that information to make more informed decisions about who gets access to what.
And the other way around is also true, right? Systems can use identity data that's being provided by other platforms through PX Grid.
Exactly. So let's say you have a threat intelligence platform that's constantly finding out about new threats, malicious actors or compromised devices, and it shares that intelligence through PX Grid. Then, an identity management system like ISE could subscribe to that threat feed. And if ISE sees a user or device trying to connect to the network that matches one of those threats, it can immediately take action, like blocking the connection or putting the device in quarantine.
That sounds really powerful, being able to detect threats and respond quickly. You also mentioned that PX Grid is good for threat response.
Right, so if a security system detects something suspicious, like a big change in behavior, it can use PX Grid to quickly get more information about the user or device involved. That extra context can then be used to trigger an automatic response, like quarantining a device that might be infected, temporarily blocking a user's access, or changing firewall rules to stop communication with something malicious, all based on the identity of the thing that's causing the potential threat.
So it basically allows for a much faster and more targeted response because you understand more about what's happening. And the last thing you mentioned was data brokerage. How does PX Grid help with that?
The data brokerage thing is really important, and a lot of people don't realize PX Grid can do this. It allows different systems that don't have a direct way to talk to each other to still exchange information, including identity data through PX Grid. So PX Grid acts as a kind of translator, helping these different systems communicate.
So even if two security tools from completely different vendors weren't designed to work together, they could still share identity information by connecting to PX Grid.
Exactly. So let's say you have an EDR platform, an endpoint detection and response platform from one company, and it finds a potential security incident on someone's laptop. And then you have a SIEM system, security information and event management system from a different company. The SIEM needs more information about the user who was logged into the laptop when the incident happened. If both of those systems are connected to PX Grid, they can share that user information easily, even though they weren't designed to directly connect with each other. This means you don't need to create custom connections between every single pair of systems, which simplifies things a lot.
That makes a lot of sense. It simplifies things and helps improve security because everyone can share information better. So managing identity and zero trust, it can't be easy, right? What are some of the challenges that companies usually face when trying to do this?
Oh, definitely. There are quite a few challenges. One of the biggest ones is finding that balance between strong security and making sure users can still do their jobs effectively. If you make things like multi-factor authentication too strict, or if your access controls are too restrictive, it can make things harder for people and interrupt their work. You have to find the right balance so that people are secure but can also be productive.
Because if security gets in the way too much, people will find ways to work around it, right? And that defeats the purpose.
Exactly. Another big challenge is integrating older systems, those legacy systems. A lot of organizations have applications and infrastructure that were built before all this modern identity management stuff existed. Trying to connect those older systems into a zero trust model can be really tough. You often need a lot of planning, custom development, and sometimes creative solutions to get everything working together. It can be a complex and time-consuming process.
I can imagine trying to get a decades-old system to talk to a brand new identity platform would be tough. And then there's the whole issue of scale, right? Just the sheer number of users and devices in a large organization.
Yeah, managing all those identities is definitely a challenge. Nowadays, users often have multiple accounts, like separate admin accounts with extra privileges. Making sure all those different accounts are managed consistently and securely can get really complicated, especially in big organizations. And things like mergers and acquisitions can make it even harder because you might have to deal with completely different identity systems that need to be combined or managed together.
So making sure everyone has the right access and that duties are properly separated across all those accounts is a big deal. What else do companies often struggle with?
Something that's really important but often overlooked is keeping all those identity details up to date across all the different systems. The accuracy and timeliness of that information is crucial for security policies and analytics to work properly. If you have outdated information about users like their department, job role, or what they're allowed to access it, can cause all sorts of problems. For example, if someone changes departments but their access permissions aren't updated, they might still be able to access things they shouldn't, which is a security risk.
That shows how important it is to have good processes for creating and removing access, that provisioning and deprovisioning stuff we talked about earlier. And you mentioned that sometimes automated updates to identity info can actually cause problems. Could you explain that a little more?
Yeah, it's something that people don't always think about, but it's important. Lots of systems use automated feeds or processes to keep identity information updated. Like an NAC system might use an identifier from the directory service to automatically figure out if a device meets the security standards. But if there's a change to how those identifiers work and the NAC system isn't updated, it could suddenly start blocking devices that should be allowed or letting in devices that shouldn't. So you really need to keep an eye on those automated updates and have a way to quickly fix things if there are any unexpected or incorrect changes to that critical identity information.
Those are all really important things for companies to consider as they move towards zero trust.